So we've all heard of Bitcoin, right? This digital currency that exists without any government or bank pulling the strings. But for all the talk, what does it actually mean to own a Bitcoin? It's a question that's surprisingly deep. To really get our heads around it, we're not just going to go through a bunch of definitions. No, we're going to do something way more interesting. We're going to build our own cryptocurrency, right here from scratch. By starting with a super simple idea and then solving the problems one by one, we'll actually end up with the core mechanics of how Bitcoin works. So, let's dive in. All right, let's kick things off with a basic idea, a ledger. Just imagine you and a group of friends are always spotting each other a few bucks for coffee or lunch. Instead of fumbling with cash all the time, you decide to just keep a running tab in a shared notebook. So this system is literally just a public notebook. Anyone in the group can grab it and add a line, like Alice pays Bob $20. And then at the end of the month, you all just look at the notebook and settle up. For a small circle of friends you trust, this works great. But it's got a massive flaw. Think about it. Because our ledger is totally open, what's to stop Bob from just adding a little something extra for himself? Like, oh, look, Alice pays me $100. We have no way to know for sure that Alice actually approved that. To build a real currency, we can't rely on trust. We need proof. So, to solve this forgery problem, we need to introduce our first piece of cryptographic magic, the digital signature. It's kind of like a real-world signature, but way more powerful. It's a unique, unfakeable mark that proves Alice, and only Alice, approved a transaction. Okay, so here's how it works. Everybody gets two keys, a public key, which you can share with anyone, and a private key, which you keep totally secret. Your private key is what you use to create a signature for each transaction. And get this, the signature is unique to that specific message. If even a single detail changes, the signature becomes invalid. And anyone can use your public key to check it, proving that it could only have come from you. So you might be wondering, couldn't someone just guess your signature? Well, the number of possible combinations is 2 to the power of 256. That is a number so ridiculously huge, it's bigger than the estimated number of atoms in the entire known universe. So, long story short, no, it's secure. And just like that, with digital signatures, our forgery problem is solved. Now, this brings us to a really core idea. The currency isn't some separate file or object. The money is the history of all these signed transactions. Your balance is just the sum total of every transaction linked to you. The currency is the ledger. Okay, great. Our ledger is now safe from forgeries. But that brings up the next big question. Who actually controls this thing? If it's just a file sitting on one person's computer, we're basically back to trusting a central authority, just like a bank. If that server crashes, or if the owner decides to block someone, the whole system is toast. We need to get rid of that single point of failure. The solution that Bitcoin proposes is, well, it's pretty radical. It's called decentralization. Instead of having one single master copy of the ledger, we just give every single person in the network their very own copy. So when Alice wants to pay Bob, she doesn't log into a central website, she just broadcasts her signed transaction out to everyone, and everyone updates their own personal ledger. But you see the problem this creates, right? If everybody is updating their own copy, how on earth do we make sure we all end up with the exact same ledger? How do we agree on the order of transactions? How does a global network of strangers come to an agreement, a consensus, on a single shared history? This is where Bitcoin's real genius comes in. The solution is called proof of work. The basic idea is to make adding new transactions to the ledger really, really hard to do. Then everyone just agrees on one simple rule. We're going to trust the version of the ledger that has the most verifiable work, the most computational effort put into it. Let's break that down. To make this work, we need a special tool called a cryptographic hash function. You can think of it like a digital fingerprint for any piece of data. You feed anything into it, text, a file, whatever, and it spits out a unique code, a hash. The key thing here is that changing even one tiny little character in the input gives you a completely different hash. And it's a one-way street. It's practically impossible to take the hash and figure out what the original data was. So here's the work. You take a bunch of new transactions and bundle them into what's called a block. Then you add a special random number to it, and you hash the whole thing together. The challenge, the work, is to find a random number that results in a hash that's very special, one that starts with a whole bunch of zeros. Because it's a one-way function, you can't predict it. The only way to find it is to guess and guess and guess, billions of times a second. It's incredibly hard to find. But once you found it, it's super easy for everyone else to check your work. That's the proof. Now, here's the part that makes the entire history secure. We add one more rule. Every new block that gets created has to include the hash, that digital fingerprint, of the block that came right before it. This is what links all the blocks together in a chronological chain. And there you have it. That is a blockchain. It's literally a chain of blocks all linked together by their hashes. Now, if someone tries to go back and change an old transaction, it would change that block's hash, which would break the link to the next block, and the next, and so on. To fool the network, they'd have to redo all that incredibly hard proof of work for that block and for every single block that came after it. It's basically an impossible task. So this all leads us to the final, beautiful, simple rule for consensus. Always trust the longest chain. Why? Because the longest chain is the one that has the most proof of work behind it. It represents the most computational effort and therefore the majority agreement of the entire network. It makes the whole ledger secure and trustworthy, all without any central authority. Okay, we've built a secure, decentralized ledger. We're almost there. But this brings up a really practical question. This proof of work thing, it requires massive amounts of computing power, specialized hardware, and a ton of electricity. So why on earth would anyone volunteer to do all of this work? What's in it for them? And this is the final piece of the puzzle. This whole process is called mining. And the person, the miner, who successfully finds the proof of work for a new block gets to do something special. They get to add one extra transaction into that block, a reward paid to themselves made up of brand new currency that's created out of thin air. This is the incentive. It's a global race to find the next block and claim that reward, and it's how new currency gets into the system. What's really interesting is that this reward isn't constant. It's actually programmed into the code to get cut in half about every 4 years. This event is called the halving. It started way back at 50 Bitcoin per block, and it's been shrinking ever since. This is what guarantees that there will only ever be a finite supply. A total of 21 million Bitcoin will ever exist. It's designed to be scarce. So let's just recap what we've built here. We started with a problem, and step by step, we've come up with a system that uses digital signatures for security, a decentralized ledger to get rid of a central boss, proof of work to get everyone to agree, and mining to provide an incentive and create the currency. And those are the core pillars of Bitcoin. When you boil it all down, that's the essence of Bitcoin. It's a system that asks us to replace our trust in institutions, in banks, in governments, with trust in mathematics and code. And that is a huge, world-changing idea. Now that you understand how it works, the really big question remains: what does this fundamental shift actually mean for the future of money?